Hello and welcome to yet another ACCE Learning Network Hangout for 2015. Hi Amanda.
Hey Roland.
It's a place we can connect the network of our PLN, share our learning and teaching adventures.
And as usual, if you're watching us live, you can post a question to the panel. You can do that three ways because we like to multitask. You can either post a comment directly to the Q&A section of this video, or you can go to todaysmeet.com/ACCELN, and on Twitter you can use the hashtag ACCELN, although tonight you might want to throw in the CE15 hashtag as well.
Thank you, Amanda. Now I'm Roland Gesthuizen, a high school teacher, e-learning leader in Victoria, Australia. I'm a member of the DLTV, and I'll save it to the next show, but I'll be changing schools, and I'm really excited about some of the things that are happening in my life at the moment.
Yay! That's very exciting. I'm Amanda Rablin. I'm an e-learning coordinator in Brisbane, and I'm a very proud QSite board member. QSite member, and I've been on the board in the past. I should read my notes correctly. Oh my goodness. Right. Well, let's meet our lovely panelists who are joining us for this evening. Dr. Zagami.
Evening. I'm Jason Zagami from Griffith University on the Gold Coast, and president of ACCE, Australian Council for Computers in Education.
That's what the ACCE part of our ACCELN thing is. I just had to say the acronym again because I'm getting so good at it. Thanks for joining us, Jason. And Wes.
Hi, it's Wes Warner here. I'm a head of ICT and business at Genesis Christian College on the north side of Brisbane.
Lovely to have you join us this evening. Now, tonight is going to be a little bit different from our normal kind of hangouts, like we have normal hangouts. As you may, and I hope you do know, it's Connected Educator Month in the US, and that kind of means it's a global thing too. And that's, I guess, because connected educators are everywhere. So a big shout out to our US viewers. That's if you woke up early enough and are watching it live in your PJs. Otherwise, if you're watching the recording, you can just say hello later.
You can come in your pajamas, or as we say in Australia, your PJs. Now, tonight's a movie night, popcorn at the ready, or it's a movie morning. Hey, Amanda, what sort of food is popcorn?
Well, I think if you're in the US, then popcorn's totally a breakfast food. I even Googled it. You can add milk and honey and just eat it like normal. But for me, it's just a movie snack tonight. Apologies if it's really noisy if I eat popcorn right next to my speaker.
Yeah, we actually have often German black bread, or we call it Roggebrot, and we have all sorts of things like Leberwurst and Blutwurst and wonderful delicacies if you're continental. Jason, I always imagine you eating a kipper on a stick.
Only if it's smoked.
Where's any random food offerings you would like to make to this part of the conversation?
I'll just be, just Vegemite on toast.
Yep, classic. Love it.
You might explain that black Vegemite, mate. It's often a bit of a mystery. I mean, there are many scientists who are trying to reproduce that strange formula.
It's a wonderful concoction.
It's derivative of actual grease, I think, wasn't it?
Wasn't it a waste product of a yeast fermentation used for something else?
Well, we used to, when I used to work as a dive master, we used to put it inside people's regulators. So when they'd go for a dive, and they'd come back after an hour and they go, "Oh, gee, the water's very salty down there."
That's right. It's got a blue healer. He wants a pat. Here we go. Go away. Now,
those Aussies are crazy.
It has, and because we're a group that's into this organic regeneration, we've been invited by BrainPOP to host a STEM-focused hangout, haven't we? And it's been thrown some videos, and we want to have a look at them, and they're free for schools to use. Now, anyone who's listening, the link is in the show notes section of our hangout, and we'll also add it to the YouTube page. Amanda, could you read out the direct link?
Because I'm the acronyms and the URL lady. The link is brainpop.com/spotlight STEM, which is STEM. And what does that stand for?
It stands for Science, Technology, Engineering and Maths. But I've heard some different derivatives of it, Jason, because I heard you could have STEAM-pressed curriculum too by adding in an A. What's happening there?
That's because the arts often get left out of things and they like to be included in funding opportunities. But there's also lots of other groups that have also tried to incorporate themselves. Textiles has been used in STEM by various groups as well, so it's a bit of an alphabet soup.
We're having more.
Another food.
We've distilled it down to just STEM at the moment, which is a way of actually getting kids to do hands-on kind of thinking, engaging them in science, technology, and maths. Really, it's engineering, which isn't in its right its own subject, but a way of building it into a curriculum. For me, I get excited. I teach technology and science. And I was interested to have a look at some of the BrainPOP Trivia that you can sprinkle in. I'm going to chuck in something right now. Apparently, BrainPOP has over 800 movies in 7 major subject areas. And I'm pleased to see science has the most number of movies. I'm just having a poke around the site here. Perhaps what we'd like to do now is actually have a look at that first movie, if I can. And I'll run it, so feel free to pop in a few words. This is Moby's favourite. Moby's the robot, and let's have a look while I get started with this. So, give me a moment while I switch across. You guys can fill in.
All right, I got the crazy Aussies again. Ooh, so we can see it on your screen now. So this is the robots video?
That's right.
So maybe, what are we going to learn tonight?
Oh, we're going to find out.
You're a robot, but you're one of a kind. And by today's standards of robotics, you're pretty sophisticated, for lack of a better word. Nothing. Most robots today may not be as exciting as the walking, talking, mechanical people you see in science fiction, but they're still pretty cool. Simply put, a robot is a mechanical device controlled by a computer. I guess they could be your friends, but usually robots don't have much of a personality. Take this guy. Industrial robots like him are used in factories. They can carry out precision tasks over and over without getting tired or bored. And while our arms have only 3 joints, a robot arm might have 10.
Yeah, but that one's got an Armstrong battery.
A robot arm might also have a full 360 degrees of rotation. This is a welding robot. When humans weld metal, they have to wear all sorts of protective gear to prevent accidents. They have to be extremely precise, and their work usually takes a while. Robots can do it faster and just as well without all the danger. Well, most robots have computers for brains. That means everything they do is pre-programmed. So while industrial robots are great at the jobs they're programmed for, they can't really do anything else. They're pretty inflexible. And some robots don't even have brains at all. They're known as remote robots or puppet robots, and they're commonly used to explore places we can't go.
And run
This guy is called Canadarm2, and it's part of the International Space Station. The arm is 60 feet long, can lift more than 100 tons, and even has a special hand attachment for precision work.
Hey, I'm going to pause it there. Jason, that's an awesome robot because it actually walks around the space station, doesn't it? Just picks itself up and just moves itself around.
Well, generally the astronauts move it around, but yes.
But what's 100 ton in space?
True.
That's where the maths comes in?
It still has mass. It may not have weight.
It still has maths. Thank you very much, Jason. Physics teachers are smiling at you now. That's true. It certainly has mass, and it's impressive when you start to look at some of this stuff in space and building autonomous systems. One of the first autonomous vehicles that actually took off and landed successfully was the Russian Buran, which was the prequel to the American space shuttle, and it was one that actually took off and landed. No one was on board, but that was pretty impressive back in the early 80s.
Since both ends have grasping tools, Canadarm isn't anchored in place. It can move all around the outside of the space station, kind of like an inchworm. All of its movements have to be controlled by astronauts inside the station. That's true. Researchers are working on artificial intelligence, or learning computers. If computers can learn the way people do, they'll be able to do new things without special programming. Kismet is an early attempt at such a machine.
Oh, that's ugly.
She's programmed to learn by observing people, kind of like how babies learn from their parents. Pick up new facial expressions and tones of voice that weren't programmed into her. And this guy's name is Pino, after Pinocchio.
Oh, he looks a bit friendly.
He actually taught himself to walk through trial and error. Yeah, I guess these guys could be your friends, but Pino lives in Japan, and Kismet lives in a museum. Oh, don't worry, there are dozens of other types of robots. Some of them are simple, like our robotic vacuum cleaner. It feels its way along by bumping into things, but sensors help it avoid stairs and other drop-offs.
Ooh.
Other robots are incredibly complex, like this unmanned aircraft, or drone. It may look like a plane, but it doesn't have a pilot.
Still have to know what that
Sometimes
means
drones
if
are
it's
controlled
information.
remotely by people, and sometimes they're programmed to carry out complicated missions with little human involvement. They can fly over a forest fire to let us know how fast it's moving and where it's headed. They can be equipped with sensors that detect precious minerals, as well as oil and gas in the ground below. And the military uses drones to spy on enemy forces and deliver bombs. Yep, we're at the dawn of a whole new era of robotics. Robotic engineers are working on microscopic machines called nanorobots. These machines will be constructed from individual molecules and measure less than a millionth of a meter across. Nanobots might help us deal with diseases and other problems. They could travel through the bloodstream, detecting and killing cancer cells without damaging healthy tissues.
That's creepy, isn't it? Crawling around my cells. Although there's enormous potential in that. And this is a slightly old video, but it's interesting how current it is, because these are still areas that we're exploring, aren't we?
It's been updated. I remember seeing parts of it 10 years ago, but they've added more bits, and so they're obviously going through an editorial update process with the video clips.
That's good to see them doing that. It's always a temptation to keep recycling some of your old stuff. And that's a problem sometimes in Australia, isn't it? Because we had a group, was it Curriculum Corp, who put together some really cool stuff, and I guess some things won't change, and it's a constant investment in it, and upgrading and updating your resources.
Tissues. Or engineers could make little traps that clean up pollution at the microscopic
Why does that look like a little sea of Death Stars?
Yes.
level.
Or pixel.
Nanobots might swarm over buildings and fix tiny cracks before they grow bigger.
There's a Dalek.
No,
Replicating.
it's still a pretty long way off, a decade or two at the very least. Speaking thereof, what time is it? Time to purchase a new chronometer? My forehead is covered with ice. May I use your restroom? If I could be any type of dog, I'd be a goat. I'll be seeing you in all the old familiar.
Oh, there are students. I wish I could sometimes do that too.
Obi? Have you seen that letter around here? I think it was about robots or something.
They're so funny.
It is cool. It is cool. Hey, just wondering with you guys, have you seen any cool robots lately?
You mean besides the one that I made with the hummingbird kit that measures the temperature and says hot or cold with a little red or blue light and a servo direction, or if the light is bright, it shows rainbow-coloured lights and said, I love rainbow.
Sorry. When I first saw that, I thought it measured the rainbow and then changed the temperature of the house accordingly.
That would be cool. It's not quite that sophisticated yet. Next version, plus nanobots.
Thank you. Well, I was wondering, with the kind of things you can and cannot do, do you reckon that we're at the stage now that next year we'll start to see the first autonomous vehicles driving around on Australian roads? You know, with your mum knitting away with her elbows in a steering wheel?
In South Australia.
What do you reckon?
That's where the trials are. The trials are starting up in a couple of weeks' time.
If you go out to the mines, you can see them working now.
Yeah.
But is that really autonomous or just remote? I had someone question me about that once before.
What, the ones in the mines?
Hmm.
They're autonomous, but with human supervision.
And I'd heard that one accident where one of the mining trucks had rolled over the edge of a cliff. Some of the sensors hadn't been properly put out.
Yeah, well, there's lots of different technologies being tried out.
When do you think we'll see these robots in schools, and what will they do? And don't say picking up the rubbish in the yard, because I think there's going to be some things that we leave for students to be challenged by.
Well, there were those robots that they had used in South Korea that were, I think, piloted or, by some Filipino teachers a couple of years ago.
There's a number of teacher robots in Japan being used. One set are being used by language teachers to teach in 5 different schools, and they have the robot that they then manipulate in the different schools that they want to teach in. But there's also other animatronic robots that or androids that are being used in various schools. So it is happening.
I've been playing around with Amanda as a autonomous vehicle project, and that's been a bit of fun. Interesting looking at different ways that we can engage kids with programming these vehicles. I'm giving a presentation on Thursday looking at how we can model and simulate traffic flow. And the autonomy comes in when you want the vehicles to actually make decisions beyond just collision avoidance, and it's really tricky. Until you actually go through the exercise of programming it, vehicles don't often know where they really are. They know they're on a road, but you need to have at least centimetre, millimetre accuracy with relation to the things around you, and that's tricky. And I can see why they use a lot of this laser scanning and doing stuff. But I begin to wonder, do you think we'll ever get to the stage that with these robots, it'll be too dangerous to put people in charge of planes or in charge of vehicles?
Well, that is the hope of the robots, that it'll actually reduce the road toll because they're able to make decisions more quickly. And but there is current debate going on about various safety features that will be necessary so that your car will need to decide when to kill you or not. Because if it's about to run into a busload of children, does it make a decision to run you off the cliff or run into the busload of children? So there's some very interesting ethical questions that are going into the software at the moment now.
I read that article as well, and it was really just incredible to think about what kind of ethics we have to program into our autonomous vehicles to deal with that. But I want to know, how would it differentiate between a group of children or people versus a group of zombies? So we'd have to consider different forms and different types.
Yes, I guess a zombie indicator should be included. But
sorry, I just spoiled a profound ethical discussion with zombies. I apologise.
But so Isaac Asimov explored these ideas many years ago, many decades ago now, with the 3 laws of robotics, or the 4 laws they turned into. So trying to actually build in processes whereby robots can have some value system or ethics has been long a bone of contention. But if the complexity of the AI is of such that it's equivalent to our own processes, then ethics may emerge naturally. We are just machines, biologic machines, nevertheless. So the assumption that we have to actually hard code ethics in may not be as valid as some people originally thought.
Well, talking about constructing, I've got another video here. This one is about the kind of environment that we might find ourselves in when we're constructing these tools, things like 3D printers. I was really quite surprised. I've often thought about that would be kind of the way to go. But what's interesting is that things like 3D printers go beyond just the tool that we might be using to like using a laser to cut something. I've heard of something which allows you to use a special sharp cutter which works off a computer, which allows you to cut cardboard to any shape you want. You could make your own craft borders or your own stencils, or Amanda, like the Make-Do card pack that we'll be sending you. You've also got laser printers. I'm going to now play a 3D printing and video. This is on the BrainPOP side, and we'll just see if that triggers some discussions and thoughts. So just switching the camera over. And go.
At Miller's Cave after sundown, there will be a fun surprise and free buffalo wings.
Oh, someone has helped me there. Buffalo wings. Now, I don't think he's really talking about it's chicken. What's this chicken and buffalo?
It's chicken. It's chicken. Yeah, it's just the spices and stuff.
Okay.
Buffaloes don't have
We call them
wings.
chicken wings in Australia.
Unless you go to Woolworths, and they're buffalo wings.
That's crazy.
Okay. Here we go. So, buffalo wings.
From Moby.
Thank you, Moby.
Hello? Moby? Dad?
This is scary.
So, you got a 3D printer, huh? And you brought me all the way down here just to show off your weird plastic army?
Yeah.
Oh. Dear Tim and Moby, I keep hearing about 3D printing, but I don't know what it is. Can you tell me? From Lucas.
Actually, before he gives explanation, Jason, I've heard that it shouldn't actually really been called 3D printing. There was another term they wanted to use.
Well, there's various types of 3D printing. You can have additive processes and you can have subtractive processes, and there's various other systems involved with the generic term 3D printing. But it's making three-dimensional objects.
Okay, we'll stick with we're not playing with the name there. We're looking at the idea of being able to make your own plastic devices and your own plastic toys. So
they don't have to be plastic.
Oh, that's true. Yes, we can 3D print our own titanium jaw.
And
Sugar.
chocolate.
Good thing, Lucas, and it looks like Moby will be able to help me. Unless you live in a cave, you've probably used a regular printer. They print in 2 dimensions. 3D printing works on the same principle, just with an extra dimension. You start with a 3D image on your computer. The image is sent to a 3D printer where it's interpreted as a stack of thin slices. The slices are printed one on top of the other. When it's done, you have a precise 3D model of your image. In most 3D printers, each slice is squirted out as a thin layer of liquid. The liquid hardens immediately, and the printing surface lowers. The process repeats over and over until whammo! There's your object, made exactly to your specifications. Most of these printers use a spool of plastic as their stock, or raw material. But the stock can be just about anything, from metal to wax to chocolate.
Chocolate? Wes, what's going on here?
Chocolate? It gives the whole new rise of 3D printed food. Anything from cakes right through to burgers. We've recently seen, I think it was one of the people from Google there was looking at investing into lab-created steak, and it would be 3D printed out after it was cultured.
Wow. I think the thing that makes me excited about 3D printing food is starting to sound more and more like that Star Trek replicator that I'm slowly moving my house towards.
I was just about going to ask you that. Just about going to ask you that.
Yeah, I had to find my connection there.
Food.
So it is really cool. I mean, being able to print your own food, your own designs, putting some novelty.
Your own house.
Even it goes beyond food, isn't it? Because we can actually print the cells onto maybe a substrate and then print a kidney. Is that some of the theories about how we can stretch it to medical products, Jason?
Well, most of the really interesting stuff around 3D printing, even from school-based, is printing various prosthetics and body parts because they do need to be very individualized. But they are also now printing organic elements and exploring the idea of printing out organs and other aspects. But almost anything that's three-dimensional and that can be built through an additive process or reasonably simple processes in that way have now been explored through 3D printing, including with concrete and houses and so forth.
That's right, someone printed recently their own house, wasn't it? A Japanese chap?
In China, they've actually got quite a production line going of 3D printed housing or apartments. But there's also 3D bricklaying, which is sort of an additive process, but with bricks instead of squirting. So there's a whole range of different automated machines that are being developed for this sort of a concept.
Mm-hmm. Well, that's a good...
Sorry.
I'll jump in. Yeah, go, Amanda.
No, mine's a random segue. Wes might be more on topic.
There's also the thought with NASA using a 3D printer for building a lunar base, just using the moon dust up there. So rather than taking all the raw materials up, just take the 3D printer up there and create the housing from there.
Hey, that's way cooler than mine. I was just going to say, I read earlier today about these booths where you have a 3D rotating scanner and then 4 hours later you pick up your own Shapey, which is that going to be the new selfie, a 3D printed version of yourself. That's not as cool as, you know, printing lunar stuff.
But I have not making. I think they've got a 3D printer now on the International Space Station where they can make all sorts of strange things and tools and, or maybe have a bit of fun. I'd like to imagine them having a bit of fun with it.
It looks pretty fun up there. I've watched a lot of videos of the International Space Station recently. My daughter is kind of obsessed with space, and it's so awesome.
It is. Okay, just hitting play again.
Yeah, it does seem like magic, doesn't it? Another kind of printer starts out with a layer of powdered material. It's most commonly plastic, but it can also be metal or ceramic. A laser traces the shape of the first slice, heating the powder so it sticks together. The printing surface drops, more powder is rolled across it, and the process keeps repeating. When it's done, all of the leftover powder can be used for the next job. In any 3D printer, each layer is paper thin, so the printing process can take a while. It might take 15 minutes to print out an extra button for your shirt, or a few hours to print a replacement case for your cell phone. Each of these Moby statues probably took a few days, which seems kind of like a waste of time. Nothing. Anyway, there's a lot of excitement about the potential for 3D printing. Inventors can now easily build working models of their ideas. Doctors can print joint replacements, hearing aids, and other stuff that requires a custom fit. Astronauts in space can print equipment they need instead of waiting for shipments from Earth. But the biggest change might be in the way everyday goods are made.
Okay, give me the first thing that you might suspect will be 3D printed in our home. Wes? The shirt button?
No, what? I'm probably thinking cutlery.
Jason?
Personally, lost car remotes.
Amanda?
Well, my house is full of little plastic toys. If I could design them myself, that would be even better.
Oh, very creative. Let's see what he has to say here.
Today, most products are mass-produced in factories. People and robots assemble thousands of copies of the exact same item and then ship them to stores. In the future, if most people have their own 3D printers, they'll be able to make a lot of these products at home. All they'll need is raw material like plastic or metal and a computer file for the item they want.
I think Amanda wins.
Well, we're still quite a way off from that. For now, printers can't make complex objects with lots of moving parts. Like, you couldn't print a wristwatch or a camera. I mean, you might be able to print each part individually, but you'd still have to assemble it yourself. As the technology improves, though, it's sure to play a bigger and bigger role in how everyday objects are made. Speaking of which, what exactly do you intend to do with this army of yours? Okay, you realize these guys are just plastic, right?
That's kind of fun. And I can see when kids are doing it, the kind of fun stuff they're doing, playing with the technology. In our project, Amanda, we discovered that the drive shaft wasn't long enough to make it through the cardboard. And one of my students, without batting an eyelid, started opening up Google SketchUp and 3D printing the extended drive shaft. And that was really quite exciting for me. Not because he was 3D printing it, but he saw this as an immediate technological fix to his solution. He had an idea, and he could visualize it, and then start to mass produce it for the 4 wheels for the vehicle.
And you can make it that exact size, you know, if you measure correctly. It's not like you're taking a raw material and cutting it down. You can design it directly.
It's important to get measurements right, because I think the way it's scaled, they were going to be about 2 meters by 4 meters. There's a lot of plastic, and it's important to get your scale exactly right when you're 3D printing.
There's a whole lot of new opportunities to push the boundaries of intellectual property and copyright law.
Now,
You mean I shouldn't print Disney princesses first?
Well, I'm sure you got permission and paid royalties, so it's okay.
Yes. Oh no, I'm just going to 3D scan myself and print that for a while.
now, do you think we should put our 2 ideas together? No, I'll come back to the next one, actually, because I think there's some ways that we could think about linking ideas from the first and the second video. Now, the third video goes back to Ada Lovelace, and perhaps if Wes or Jason can fill us in. Why is she called the Queen of Programming?
Well, because she was the first programmer. Well, she wrote the first computer programming code for the first, well, one of the first mechanical computers, the Babbage analytic machine, or whatever it was called. But she was very instrumental in developing the first programming languages and in deciding to try to make programming languages generic, so that you could write a whole range of different sets of instructions instead of just writing customized sets of instructions for any one particular machine to perform.
Do you reckon, Amanda, that we don't do enough perhaps to promote the role that women have played, especially people like Ada in the past, with bringing technology to bear and launching a whole new generation of computational thinking?
I think we need to celebrate all of the people who have contributed to these amazing developments, but I think there's still a stigma about it not being a particularly girl thing to do, and I think showing that we have these strong role models who have made such a significant contribution to where we are right now is so important.
Now I'm just loading up the Ada BrainPOP video. You guys can chat for a little bit, just get that loaded up.
I sang the hold music the last time, so someone else has to do it.
Well, the question I might put to you then, oh, okay, it's loading up, cool. This is Ada Lovelace. There's a BrainPOP pop. And switching over my Hangout. Here we go. Ada Lovelace.
Oh, just playing around with these old circuit boards. Yeah, let me see. Dear Tim and Moby, could you please tell me about Lady Ada Lovelace? From Sean. Sure thing. Augusta Ada King, Countess of Lovelace, is considered by many to have been the first computer programmer. She was born in London in 1815 to Anne Milbank and the poet George Gordon Byron, better known as Lord Byron.
Lord Byron? That is a familiar name. Does anyone know any poetry from Lord Byron they could quote, or something about Lord Byron?
He wrote it was a poem about a guy locked up in a castle on the shores of Lake Geneva. But
Not the man in the mask. That's all right. But she had obviously a very noble background. So let's see what some of the more noble things she did with her programming.
A month after her birth, though, Ada's parents separated. Ada stayed with her mother in London while her father left the country. Ada never saw him again. Yeah, it was kind of a rocky situation. Ada's mother wasted no time in taking charge of her daughter's education, though.
Good on her.
She'd been interested in mathematics herself, so she strongly encouraged Ada to develop a mathematical mind. She hired private tutors to help teach young Ada, who grew to love working with numbers. Unfortunately, though, Ada was often ill. She suffered from severe headaches and became paralyzed at 14 after contracting the measles. It took almost a full year in bed for her to recover. Well, it helped that she could enjoy homeschool tutoring from some well-known scientists and mathematicians. One of these was Scottish researcher and writer Mary Somerville, who became both a mentor and friend to Lovelace. Somerville encouraged Ada to follow her mathematical and scientific studies and introduced her to various scholars of the day. One of Somerville's friends was mathematician and inventor Charles Babbage. Lovelace became fascinated by Babbage's work, in particular, a machine he'd invented called the difference engine.
Now, I'll just pause it there. That's a pretty mean-looking machine there. It's almost like something used for the looming industry for making carpets. What did the difference engine actually do?
Well, it worked out differential equations. No, it did calculations before they actually had electronic computers. It was a mechanical computer. Well, it was designed to be a mechanical computer to solve mathematical problems.
Ah, so here's the coupling. You've got Ada, who's been coached and is passionate about mathematics, who now has access to a machine that allows her to maybe realize some of this. Let's hit play.
She paid Babbage a visit in order to see the difference engine in person. It wasn't finished yet, but the machine could automatically calculate mathematical equations in a way that no device at that time could do. She was only a teenager, but Lovelace understood how the difference engine worked and knew it had the potential to be very important. Oh, actually, that was something else.
With a light bulb.
Another of Babbage's ideas was for a device called the analytical engine. It was designed to add, subtract, multiply, and divide numbers, derive square roots, and make comparisons. The machine could do these things by reading instructions on punched cards.
Oh, that brings back memories, those punch cards. But they were, I believe, that was used often in the weaving industry for being able to automate some of the processes in those machines. But how were they used with computing?
The same process, giving a set of instructions. But the key invention was that it gave a set of instructions on what to then do, rather than most often things were hard-coded into the actual looms, where a loom would only perform one particular pattern because that was what it was set up to do. The idea of the punch card instructions was that you would feed the instructions in first, and that would then give instructions for the loom to do different patterns.
Now, if this is similar to knitting, is knitting a form of computational thinking in the way that you'd process the score or algorithm for constructing a series of finger movements that are formed into a repetition into a sock?
Well, knitting is a... Sorry, go on, Amanda.
So I was just going to say you have to manually perform every step in a loop. It's really frustrating, so you can't work with your code in that way. But there are knitting machines.
But are they
help.
computational machines? I mean, is it a form of computational thinking?
It's an algorithm.
It's an algorithm, is it?
Yeah.
But it's a mechanical algorithm. And as it doesn't rely upon a computer, it depends upon your definition of computation. And like the original computation processes, and in fact the original computers were people who performed algorithms. But in terms of what we would now refer to as digital technologies as a subject, knitting might be an example of an algorithm, but it wouldn't necessarily be an example of a computational thinking process, because it doesn't then relate directly to a computer, except to show how a computer could do things more efficiently and effectively than a manual knitting process.
I'd be curious to see if you can Google us in the background if anyone's developed a knitting machine that actually simulates the knitting movements to knit me a sock using a computer. Here we go. Can a robot knit? Okay, here we go. I'll let you guys look that one up in the background.
You're getting ahead of me, and please don't do that to my boards. Anyway, soon after Lovelace met with Babbage, she married a scientist named William King. King was a nobleman, so he went by a bunch of fancy titles, including Earl of Lovelace. That's how Ada became known as Ada King, the Right Honorable Countess of Lovelace. She had 3 children and quickly went back to her mathematical work. Then, in 1842, another mathematician wrote a detailed description of Charles Babbage's analytical engine in French. By that time, Babbage had grown quite impressed by Lovelace's intellect. He'd even given her an endearing nickname, the Enchantress of Numbers. So he asked her to translate and take notes on the French description of the analytical engine for him. Lovelace worked on this for 9 months, adding many of her own unique insights and calculations. Her notes included a plan for how the engine could calculate a sequence of numbers called the Bernoulli numbers. Today, many historians consider this to have been the first computer program, and Lovelace the first programmer. Computer programs, by the way, are the all-important instructions that computers need to perform any function. Lovelace also predicted that computing machines might one day be used to do things like compose music and create graphics. Yeah, she sure was right about that, and we're living proof. Seriously though, Lovelace was a visionary in many ways.
That was probably Lovelace's greatest contribution, in that she saw that computers, the analytic machine and so forth, could be used for a whole lot of different things other than just mathematical calculations. And that led then to the development of the much more generic computing programs and processes that we now see in computing today.
Do you think we don't invest enough in some of the other great women who were digital pioneers, like Margaret Hamilton? I think that name was quoted earlier.
Yeah.
Well, I think we need to recognise all of our leaders. Often male mathematicians and programmers don't get an awful lot of recognition either. But one of the problems is that there is the percentage of women in the industry is so much lower that they get a commensurately then lower recognition as well. So in order to boost the number of females in computing, anything that can be done to highlight the successes of females in the industry is obviously a good thing.
That's a good point. And I think it would be a good intro for students when we're introducing computer programming in the classroom, way of pitching it. Do you think that there's a good story here that we should be sharing with our students?
Which story?
Oh, the story of Ada Lovelace. I'm wondering if there are some good lessons there to be learned.
Oh, absolutely. Well, it's her contribution is a fundamental part of the historical development of computing, but she is almost always included in descriptions of the history of computing, and rightly so, of course, for a great contribution. But I think we do need to go beyond that in terms of the gender issues. Just mentioning a few key people is probably not going to be sufficient. There's a whole lot of other aspects of getting more girls involved. And the digital technologies curriculum should hopefully address a lot of that. Of course, most of the problems do tend to happen around puberty, and by having students engaged with computing all the way through their schooling, they should hopefully develop an interest and passion for computing long before they start becoming focused on other interests.
That's a good point, Jason. And for me, part of the story that appeals to me of the Ada Lovelace is that if you support someone and encourage them and stimulate them, you can develop a passion. It would have been unusual for a woman perhaps at that time to take up an interest in mathematics and a research one too, where you're developing something like programming. For me, what resonates is that if you can do that with Ada Lovelace, maybe other parents can do it with their children by stimulating interest in providing a rich programming learning environment. And there's good lesson perhaps for primary school teachers to be given the resources to be able to run those sort of rich experiences for the students in their class.
Absolutely, but I do think we have to recognise that Lovelace was an exception. She was very gifted, and particularly in mathematics and so forth. So what worked for her may not work for every student, just as what worked for Einstein may not work for every student. So we do have to look for much more generalizable processes to get every student engaged with technology and the opportunities it provides.
Now, the fourth movie is about binary code, and it's always tricky how we teach it. Everyone's got their own quirky way of doing it. The worst way to sit down and write zeros and ones on the board. I don't think students have issues sometimes with the numbers, but often in understanding why we do it. Do we start with teaching electronics? Do we start before they actually start tackling a computer science project? What do you reckon?
Well, my preferred process is coding and decoding. Students are often quite interested in creating secret codes and decoding codes, and binary is a nice simple way of doing that, and getting them to recognize that there are different ways of representing information, and coding is, particularly binary coding, is just one of those ways, and then they can go along to look at more efficient ways, such as hexadecimal and other coding forms.
It's interesting, Jason. I do something similar. I teach my students Morse code, Braille, and these are symbolic gateways to understanding something a little bit deeper. With Morse code, it's a way of a light flashing on and off to give a coded alphanumeric sequence. Braille, a very tactile environment, but also a coding for being able to give information, and binary in a sense for being able to codify information that can be processed by computing for solving problems or calculations. Mostly with the jump command, of course, but that gets a bit hairy when you're throwing them into machine logic. Wes, what are your thoughts?
I think any which way you look at with binary, always introduced with a bit of humour there with Futurama, but you're obviously got to pick your parts there with Futurama, with teaching their kids with binary, but but it's a great way to sort of look at it or start with it.
There's a couple of classic scenes in Futurama, isn't it? With was it where Bender is reading binary numbers on his console? 0 1 1 1 0 1 1 1 1 0 0 1 1. Yes,
to get into time travel, and there's also the one that he recites the sort of like the, I think it's the silicon prayer where he talks to the silicon god in zeros and ones.
Give me some lovely ideas. I must go back and collect those and add them to my collection. Anyway, here's the BrainPOP video on logic gates and binary. So let's see how they kind of handle it and move it forward. Screen share again, and I'm getting better at this.
To be fair to BrainPOP, most of the information is contained in the stuff around the video, not actually the video itself.
That's a very good point, Jason. Actually, I might just point that out here. You've got the Zoom movie, math, algebra, some of the related topics, computer history, and I've noticed also lots of activities around here. So it's more than just a video. This is really a springboard into all the other things that they have, and that's part of the POP, I suppose, when you pick up an idea and an interest, and you can go back and explore it further. Thank you, Jason. Here we go.
Coming home from school, gonna jump in the pool. Bam, bam, bam. Oh, hey. Can I? No.
Oh, that's so cute.
Moby! An android? What's with that guy?
Okay, let's test your knowledge. Who can recognize who that little fellow was? Where's?
He was a logic gate.
A logic gate. Okay, he wasn't going to let him in until some condition was satisfied. How many legs lit up there, Amanda?
Well, there was 2 legs and then his head.
Okay, and it's about to explain how the logic gate actually works.
Dear Tim and Moby, why does my phone get hot when I have a lot of apps running?
Yeah, for me, especially this week, it's been Facebook until I've upgraded it, so it's much better in the way it handles power.
From Sylvie. Hey, Sylvie. If you've ever opened up an electronic device, you probably saw one of these. This is a circuit board. It holds the main parts of a circuit and controls the flow of electricity to them. Close up, you'll see something like little pathways. In fact, that's just what they are, paths for electricity to flow from one piece to another. Right, as electricity streams through the circuit, it's also passing along tiny pieces of information. The current is actually pulsing in a kind of code called binary.
Of course, there's on the flip side of the board, we've got all the other circuits and bits and pieces. This is actually really quite tricky sometimes for kids to get their hand on, because I reckon when we're often doing a lot of computing, it's all this mysterious black box. I've got to look inside. How often get kids the opportunity of breaking open a device and having a sticky beak at the circuitry? I think we've all done it, but I'm beginning to wonder, unless they're sort of rummaging around the rubbish piles, it doesn't happen.
I think also with that, Roland, is the fact that the way the pricing of desktop computers have come down so much these days. The idea of actually building your own isn't as cost effective as it used to be.
What do you think about it? Do you think we do enough to explore inside these machines?
I think it's always fun to take things apart and work out how they work. Isn't that just part of the process of learning about them?
Yeah. So let's play this one a bit further.
And the Arduino and Raspberry Pi and all of those are based on the idea of making those circuits visible.
Okay, we'll just play this video.
Yep, binary is usually represented as ones and zeros. These values are known as bits, but they don't have to be numbers. You can make a binary code out of any unmatched pair. Braille is a special kind of binary where the bits are raised dots and blank spaces. In Morse code, the bits are long and short pulses of sound or light. And in digital circuits, the bits are a low voltage and a higher voltage. In other words, computers and other electronic devices think in a binary code made of electricity.
This really pleases me in the video because as a science teacher, I get annoyed and sometimes it gets dumbed down to zeros and ones flowing along a wire. And that's not what really happens, Jason, is it?
Well, if you're talking telecommunications over very long distances, it sort of is. But in a circuit board, no, it's not. It's much too quick for that to be.
Okay, I'll accept
You
that.
have the concept of packet, which does represent a flow. So it's.
Am I being too technical, or am I right to dig in on this one? What do you reckon, Wes?
Oh, column A, column B. Yeah, you're both right.
It can't be right. Zeros and ones are high and not so high.
Well, it depends on what level you want to go into. How to best describe it. Sort of, if you sort of get it with the zeros and ones running along there, by all means, you're getting the concept.
Yeah. Jason knows where I'm coming from. I wrote a paper on conceptual understandings of computers, and there are kids who actually believe that little cats are running along the wires. And I know where that's coming from.
I thought they were Tron cycles, light cycles.
Yeah.
One day we may discover that they really are.
Here we go. Let's have a look at the gates.
Code, they rely on something called a logic gate. A logic gate is sort of like an electric switch. Binary bits of electricity flow into it through one or more inputs. Depending on the value of those bits, the gate will send a 0 or a 1 as an output. Our little friend here works like an AND gate. His output voltage will only be high when both inputs are high. If one or both inputs are low, the output will be low. We can view these combinations in a truth table. See, the output is 0 unless both inputs receive a 1. Right, the house alarm is a good example. The siren will only sound if it receives a 1 from this AND gate. One of the gate's inputs connects to the keypad. Pressing on sends a 1 to that input, otherwise it gets a 0. A motion detector connects to the other input. It sends out a 1 if something inside the house moves. So, if the system is on and something moves, the AND gate gets 2 1s. That means it outputs 1 and the siren goes off. Oh, right, the back door. There's a motion detector there, too. That means we need to add an OR gate to the circuit. Now, if one or both detectors gets tripped, a 1 will be sent to the AND gate. And if the system is on, the siren will sound. I was just getting to the windows. Each one has a NOT gate attached to it. NOT. When a window is closed, it sends a 1 through the gate. The NOT gate reverses that to a 0, and the alarm won't sound. If a window is opened, it sends a 0 to the gate. The NOT gate changes that to a 1, and if the system is on, siren sounds. Yeah, once you start stacking gates together, they can make some pretty smart decisions. And this circuit is still really basic. It has one purpose and only uses the simplest 3 gates. Alright, bring out their friends. There are 4 other basic gates, each with its own specific truth table. The NAND gate. When she gets too much juice, she shuts down. The NOR gate. This guy likes zeros. Simple as that. The XOR gate. When she gets different inputs, she's a happy camper. And the XNOR gate. He's matchy. He likes it when his inputs are the same. Computers have millions and millions of these gates packed inside them. They're clustered inside a computer's microprocessor, the part that manages all your apps and programs. The gates here are specially arranged so that they can process information from lots of different programs. So whether you're finding your position on a map or spinning tiles before they fall, the circuitry is always doing the exact same thing. The only difference is in how each program uses it. Oh, right, those millions of gates are why your phone can get hot. The more apps you're using, the more bits the gates are processing. That's millions of electric pulses per second, and they throw off some heat. Aw. Poor little guys. Gate is Enough was filmed before a live studio.
Filmed before a live studio audience. What do you guys reckon? I think that handles it really nicely, actually.
I think a video is never going to show enough. Kids need to actually make their own gate circuits and see the results. And you can do that on the computer or you can do it physically, but I don't think you'll ever get it from watching a video.
But it was really cute.
It was cute.
Step up on top of each other. It was cute.
It's a good intro. But as Jason said, you really need to break the kids into doing something physically, and get them involved there. But it's a good,
that's where I would.
Stuff.
That's where I would use these resources.
I've got something here to share. So, Jason, kind of construction you're thinking of is perhaps a little bit like this. this is how you can build your own redstone logic gates. Minecraft has a whole series of circuits there. There's some strange electrical behavior in there, but I rather like that you can build a NOT gate, you could build an AND gate, a NAND gate, an OR gate, a NOR gate, an XOR gate.
But it all comes down to students solving problems.
Yeah.
And that makes it useful for them.
And you think Minecraft would be a good hands-on way of learning some of those gates?
Oh, absolutely, although it's a little bit complex. For younger kids, I'd probably just get them straight using some of the very simple electronic kits that they can put these together and make lights light up and not light up. Minecraft works well because kids are really engaged with Minecraft and they want to learn more about Minecraft itself. How much they then really want to learn about XOR and NAND and all those sort of things is probably debatable.
I love the idea of actually doing electronics. I ran a unit where we were poking the circuits through cardboard, and I was surprised how cheap it was. You don't necessarily have to buy the multi-dollar kits. You can often buy just big boxes full of resistors and gates and stuff, and just have a bit of fun. There are plenty of tutorials on the web for you to learn how to do some of this.
Yep, and there's now you've got the electronic ink pens where you can trace out your circuits on paper and put a few little transistors in there to create your circuitry. But back to our original conversation on 3D printing, there's a lot of excitement now about actually printing three-dimensional circuit boards and the advantages that may come out from that, and that can be done even in a school-based system. Of course, if you've got the electronic ink, you can then print that out and create your own circuit boards. Again, reasonably simple ones because they're not going to get very, very tiny, but you can get some quite complex circuit boards printed out on a large sheet of paper.
That's really impressive. So there are ways of mashing some of the things we've been seeing tonight into different bits of technology.
And produce your own robot.
I was thinking more of actually taking some of these ideas, and if we could get the right sort of 3D matrix that I can then place the stem cells on, and then add the artificial intelligence with the original robotics, and incorporate some of that wearable technology, we could actually print our own teacher.
We possibly could. Whether or not you want a 3D printed teacher,
customized to your needs.
But if I scan myself first and program it a little bit, and it looks like me, will anyone know?
You could have longer holidays.
We laugh about it now. I remember asking a couple of years ago what you guys thought about how we might be heading, and we were scrubbing all sorts of silly things. But it's interesting to see some of the bits and pieces with this technology and how it's leveraging change. The last movie I wanted to wrap up tonight, if I can, was about electromagnetism and Wi-Fi. We've got time for one more?
Sure.
Okay.
Sure. I still have some popcorn left.
Well, just give that bag a bit of a shake there with the popcorn as I listen to this video. And
here,
this one,
I'll give you some.
Nikola Tesla. And I'm really glad because I don't think this guy gets some credit sometimes for the work he's done.
He makes great cars, Roland.
This wasn't the Tesla car, but I do think the Tesla car was named after him. I remember there was a big bum fight he had. If anybody wants to look it up, when they were designing different ways of executing the electric chair between AC and DC, Thomas Edison. But I think you've just focused on some of the things he managed to come up with. AC current comes to mind. Jason?
I'm not an expert on Tesla, I'm afraid.
Now,
I know he was involved with the big debate around the invention of the light bulb and so forth, but that's about it.
Yeah, they must have been exciting years when many inventions are being cranked out by various labs. I guess Thomas Edison had his lab that worked on all the different prototypes for the electric light bulb. Let's have a look to see here what Nikola Tesla has contributed to science and technology.
Once I harness the power of lightning, I'll be able to rule the world!
Oh, that's so out of one of those movies. The Metropolis.
Frankenstein? Oh.
Yeah. I love this stuff.
Oh, yeah,
I must go back one day and sit with my friends through the Metropolis movie. I just love the Queen soundtrack on it. Here we go.
Thanks. Dear Tim and Moby, my brother says Nikola Tesla was the most amazing guy ever. I say it's Batman.
It is Batman.
Who's right? From Elena. Sorry,
Superman.
Elena, but your brother's right. Tesla is way cooler than Batman.
No.
He was born in 1856 in what's now Croatia. One day, when young Nico was petting his cat, a spark of static electricity jumped from his fur to his hand. At that moment, he decided to spend his life studying electricity. He grew particularly interested in its link with magnetism. The relationship between these forces lay at the heart of Tesla's greatest inventions. It had long been known that electric currents produced magnetic fields, and that moving a magnet near a wire would create a current in the wire. Moving a wire through a magnetic field had the same result.
Oh, I have fun with this in science. So I'm building induction motors and linear motors. There's some really cool experiments you can do using magnets and wires and batteries to make things spin.
This phenomenon, electromagnetic induction, was behind the first practical generators and motors. Using induction, you could convert motion into electricity, and electricity back into mechanical motion. By the time Tesla was a young man, electricity was powering industrial equipment and lighting up buildings. But he had already thought of designs that would greatly improve the technology. Well, induction naturally produces alternating current, where the direction of electricity switches back and forth. But AC was tricky to work with. Engineers couldn't figure out how to build a decent AC motor. So early generators and motors were built to work with direct or one-way current. In these systems, the key moving part, the rotor, had to physically rub up against the power source over and over again. They wasted lots of electricity, and their parts wore out all the time. Plus, all those sparks were a constant fire risk. In the 1880s, Tesla began to develop an idea for an AC motor, but his plans weren't going anywhere in Europe. So he set sail for America. He landed in New York, where he went to work for the world's most famous inventor, Thomas Edison. Edison had just developed the first power grid for electrifying entire cities. It was revolutionary, but like everything else at the time, it relied on DC power.
There was a problem too, wasn't it, with standards, because no one had any written standards, and I think at one case in the UK they had several voltages that were running across different appliances and networks.
Well, we still have. If you want to try to use a PowerPoint in different parts of the world, or 110 versus 240 volts.
Was that a form of control, you reckon, back then, or just that everyone had their own favourite voltage?
I always blame the French. They always want to do their own thing.
The power plants had to generate low voltages that would be safe to use in the home.
Oh, here we go, voltages. Now we've got those volts coming on the wire again. The zeros and ones now got electrical volts. Although maybe they're electrical, maybe there's a DC and that's electron. Well, actually, there won't be electrons moving. It's really the holes. Depends which way the current is. They got that one wrong, didn't they, Jason?
In what respect?
Well, the flow of electricity wasn't actually the flow of electrons. It was actually the flow of the holes left behind by the electrons as they move the other way.
Yes, there is. Yeah, there's a whole lot of complexities of that.
I like to play it to get them really.
It's the same as with lightning bolts. The actual bolt goes from the ground to the sky, not from the sky down initially. That freaks students out.
It does actually. They're the ones that are hair raising.
Such a weak current couldn't travel far, so lots of plants were needed. But Tesla envisioned AC generators that could crank out 1,000,000 volts. That meant fewer power plants, since high voltage can travel much farther.
It's missing a coal mine.
No, you're right. It'd be really dangerous if 1,000,000 volts came out of your wall sockets. But Tesla knew that he could reduce AC current to safer levels with a transformer. The high voltage runs through a large coil, creating a strong magnetic field. That induces a current in a smaller coil nearby. The smaller the second coil is, the weaker the current that's induced. So after you run high voltage through a transformer, it's perfectly safe for home use. No, Edison hated it. Since he owned most of the patents for DC power distribution, he'd lose money if cities switched to AC. So Tesla quit working for Edison. But soon, his ideas attracted the attention of a rich industrialist named George Westinghouse. He wanted to build the AC motor Tesla had been dreaming of for years. It was an ingenious design. The central rotor had wire coils on its ends. A set of surrounding coils were electrified in a precise sequence. Their magnetic fields would induce a current in the rotor's coils. Then, the competing magnetic fields would cause the rotor to spin. This induction motor was light years ahead of anything else at the time. Unlike older models, it ran on AC, and the rotor spun without touching anything. Today, variations are still used in everything from cars to air conditioners. Next, Westinghouse used Tesla's AC power system to light the 1893 Chicago World's Fair, which was like a 19th century Disney World. 27 million visitors saw AC in action, and just like that, the war between alternating and direct current pretty much ended. Today, almost every electric system on Earth distributes AC power. Nope, Tesla wasn't finished. Soon he undertook a series of experiments in wireless energy transmission. His dream was similar to the wireless technology we enjoy today, a system that could beam all sorts of information around the globe. The key was high-frequency electricity. Well, the AC power that comes out of the wall has a frequency of 60 Hertz. That means the current switches direction 60 times a second. Tesla built a remarkable device that could boost the frequency to hundreds of thousands of hertz. It also boosted the power to millions of volts. It was called the Tesla coil. It could be modified to broadcast radio waves for miles and miles. And in fact, that's just what an inventor named Guglielmo Marconi used it for, much to Tesla's dismay. Tesla couldn't convince the courts that Marconi's radio had infringed on his patents. He kept working on his own projects, including a way to transmit electric power wirelessly. He also said that he was working on an energy beam weapon, a force field, and a camera that could take pictures of thoughts.
Tell you what, that guy should be working for Pixar. It's really impressive, some of the brainstorming and the ideas he had.
Luckily, Will Smith and Kevin Kline were able to kill him off before he finished his invention, though.
It's pretty impressive stuff to go in all those different directions, though, isn't it, really? A force field. I mean, was he maybe dabbling in science fiction writing and we just picked up the wrong book?
No, well, he was at the very edge of technology, so he was able to explore things that no one else had thought of at the time.
Well, I think the whole idea about peering into people's thoughts is a little bit NSA or GCHQ type stuff.
But he's correct in the ideas that we're actually now, the brain was electrical and maybe it has nature. And you think about some of the brain scanning that we're doing. This guy was right on the edge of just being able to push it forward. Perhaps at that time it'd be dismissed, but what about now?
From memory, most of his stuff was around trying to use electricity to stimulate the brain. So he was sort of very much leading that sort of process of brain stimulation with electricity. I don't know if I don't think he ever got stuff into reading thoughts or anything like that.
No, but it's great to see the sort of creative mind that's at work there. And I can get some clues when I look at this end point in his life, perhaps how he was at the start, where he'd made the jump from a DC motor to the complexity of an AC motor, which resolved some of the problems that the DC had. Just playing on.
But he never took notes, and some of these ideas were probably fantasies. As he got older, he started suffering from serious mental illness. When he died in 1943, he who's broke and remembered more for his eccentric ideas than his serious ones. That same year, the Supreme Court ruled that Marconi had, in fact, used Tesla's patents. And these days, the public is more aware of Tesla's accomplishments. An internet campaign even raised millions of dollars to preserve his New York laboratory. The goal is to turn it into a museum dedicated to Tesla's legacy. Oh yes, there'll be a Tesla coil, all right. One large enough to communicate with the Alpha Centauri system.
And get to Tomorrowland.
Thank you. Oh, that was entertaining. Did they build that museum?
I'm not sure.
Kind of curious now. But it's nice to think about something that might recognise his work. Wes, you wrote something down about induction engines and neon lights. What were you saying there?
Yeah, they were his inventions, or one of the ones that have been credited to him. So obviously the induction engine is something that we can't really sort of live without, and the neon lights, it's such a fantastic thing. It's one of the things I always wanted in my bedroom when I was a young teenager.
I love that thought. Do you reckon that when you think about the kind of experiments you might have done when you were a kid with electricity or with your students, what are your favourites? Ones you can fess up to?
The electricity.
You've had. I remember you showing me something. Oh, was it a year ago with the rocking horse?
Oh, are you talking to me?
Yes.
Oh, okay. Santa made it. So my husband and I made a rocking horse for our daughter for Christmas because she wanted a yellow rocking horse with rainbow hair. So we added LEDs, but we didn't have enough time to finish our experiments, but we were working on a series of coils to get the motions of rocking to actually power the LEDs, but time ran out and we just have batteries. But we can look into that again, I think. It can be a science experiment with her. 4-year-olds can do that, right?
Could a 4-year-old build a Tesla coil? That's an idea.
The rocking horse could shoot electricity out of its nostrils.
It could, yeah. Or it's unicorn horn, and then it can be a little bit like My Little Pony as well, just to bring the pop culture links in.
Do you reckon if Tesla hadn't gone so crazy that he may have discovered Wi-Fi, was it a reality in his time?
Well, I don't think he was really focused on communications. There were others that were exploring how electricity could be used for communication with the telegraph and the phones and all the rest, but I don't think Tesla was actually looking at that particular technology.
Good point. So it's probably more of a collaborative thing where each scientist can contribute a part of the puzzle that became life at the turn of the century. Why was America a better place for Tesla to try out his inventions? I mean, he wasn't able to sort it out in Europe.
But the tariff rates.
Good tariff rates. Taxation, was it?
Yeah, so he got the 44 cents a kilowatt hour there. So,
is there a real story here for students that we sometimes skip over? Perhaps with Thomas Edison taking the perch for the light bulb and for all the other inventions his laboratory cranked out?
Well, I think it was just
sorry, you go.
I think it was just a great collection of free thinkers at the time, and they were allowed to express themselves beyond the constraints of various institutions, in particular the churches and so forth. So there was just, like in the Renaissance, it was just an opportune time when people were gathered together and the culture built up around exploring things, much as it has in Silicon Valley at the moment.
So good timing.
And that ability to disagree with each other, to refine and challenge the ideas.
That's a good point. I mean, perhaps Edison wasn't so much a competition as much as a stimulator for Edison to try harder, for Tesla to try harder and come up with new ideas. A catalyst for innovation, to do something better.
There was a surprisingly few people actually involved in all of those inventions. It was only a couple of dozen. So it's not really quite like the powerhouses of industry that we see now. There were just a relatively small culture of scientific inquiry, and of course they all spoke to each other and talked to each other and compared ideas, and it just generated a lot of great inventions in that space.
Why America? Is it just positive? It must be more than just positive taxation, just a nexus of the right kind of people, connections, stimulating environments.
Well, it's the same reason why people go to Silicon Valley now from all over the world. The very smartest from India and China and that go to certain universities in America and then form the industries that emerge out of those. The same thing would have been happening in the very early years of America. People that were quite intelligent saw the opportunities that they didn't have in their countries because of various other repressive processes with the social structures at the time, and they chose America as the best place to go. So you had the very smartest people leaving and then gathering in a very small location and generating lots of very interesting things.
Do you think that happens enough in Australia, Wes, perhaps, with innovation and creativity? The investment that we have in pure research and adaptive research, great institutions like CSIRO being fully funded?
Yeah, look, I think we try. Obviously, the CSIRO is one of those, like, shining bright lights that we do have with what they come up with. But like even with the recent talk about the Fortitude Valley here in Brisbane becoming the new Silicon Valley, it's a little bit laughable in lots of ways. I think, as Jason sort of said, the thinkers are in Silicon Valley. It's going to attract those people primarily because they were the first.
True. It means maybe letting go of the ideas of the things that you have always been doing. We do very well out of mining and out of rural industries. I guess sometimes we forget that we've got industries like the cochlear biomedical implant program and even making components for satellites. That requires a core base of pure research and also some technical understanding about bringing products to market. I think like some of the systems that we're trying to get into at the moment with vehicle communication, autonomous vehicles, there's an opportunity here for us to move into. But it does require the cultural mindset that you have a stimulating environment in schools, encourages kids to solve and work through problems hands-on, and a stimulating corporate environment that allows people to become adaptive at being able to use this technology and to know that there's going to be from your startup some good funding to be able to take it past the development into production. There's a risk of doing that. And lastly, I think there's an opportunity to understand about intellectual property. You've got the CSIRO that hung on very carefully with some of the early Wi-Fi type patents, and that was from some of the research they did with was it black hole or help me out here, Jason. Some of the early work that they did when they were developing the Wi-Fi technology that allowed them to hang on to the patent, which gave them the royalties from the various Wi-Fi devices around the world.
Yeah, I know that they got some of the patent stuff, but I don't know any reference to black holes there.
Yeah, there was the some of the physics that was associated with not entanglement, but in signal generation and being able to decode those signals. And you wouldn't have seen that originally from the research, but it applied itself very naturally for how you would actually do the signal processing.
Okay.
It makes it hard for maybe some scientists to sell their work or the immediate application invention, but if you've got an environment that allows people to play with these ideas and to explore them, then you may have the serendipity of having that invention maybe coming from that. Is that what STEM's about? That we're trying to recreate that in the classroom? A creative place where people can play, explore, learn, adapt?
To an extent, but I think we're never going to achieve the success of Silicon Valley in trying to copy Silicon Valley, because everyone tries that. If we really want to be innovative, we have to be trying to think of doing something different and something that's not been done by Silicon Valley. And that's where we would really be an innovative country and have the opportunity to be in the lead and the forefront of things. So I always get a bit worried about trying to replicate Silicon Valley here in Australia. By that very process, it's impossible. So otherwise, everyone would be doing it. The strength of Silicon Valley is that they're not trying to replicate anyone. They're trying to be out there ahead of everyone and doing things very differently. And that's the mindset we need to get into. And that's what digital technologies and the other creative industry type approaches is, to get us thinking and confident enough to be able to do our own new things, not just try to do what other people have done.
That's a really good point, Jason, especially for the digital learning culture we're building in schools with our new curriculum.
Absolutely.
Wes, what are your thoughts? He's got his microphone off, I think.
Wes, you're muted.
It tends to be my life. You caught me midway there, because with STEAM or STEM, I think it's trying to get that holistic approach, looking at real life endeavors where it's sort of, encouraging all different facets of our life. And it was just something on the weekend I was reading from MIT, where some researchers came up with the visual microphone, where they were able to, with high-speed cameras, able to extract the audio from the vibrations of a chip packet or some leaves on a plant, and I thought, wow, that's so incredible. And looking at how many other real-life situations where this could be applied to, and then thinking, wow, nothing's a secret now if this is the case. And I think STEM or STEAM is about sort of encouraging all these different areas and all these different bits of expertise all into one area, without sort of like saying you're going to do maths now for the 40 minutes, you're going to do English for the next 40 minutes, and then you're going to do science. Where you have it almost as a holistic approach, you're encouraging all those different thoughts and all of those different skills.
It's almost, isn't it, Wes, that we're undoing the damage done by siloing some of our knowledge, by accepting that the real world is a much more complex beast. I mean, that chip packet brings together physics and acoustics, communication, and even, I know the equipment they're using, the high-speed photography, being able to record these very tiny crinkling movements in a room on a chip packet to reproduce the sound. And the fascination for me is that you can actually come up with something really novel by weaving this all together. And Amanda, you've had some thoughts too.
No, I was just saying, I wonder how, if you follow that back, the development of that visual microphone, where did those thoughts start? What was the design process? What kind of thinking went into that? How on earth did the people come up with these amazing ideas? How do you come up with AC? It's incredible. Or a difference machine. So cool.
I might not have it right, but I think they started off with, they were looking at a blanket hanging on a washing line, and there was the barest of a puff of breeze. But what they were able to do by using some of the high-speed photography, they were able to speed up the whole camera work, so they could actually show the movements of that blanket and amplify it. And just using an algorithm, you could actually begin to see the flapping in the wind when there wasn't a breeze, that there was this vague, the barest of a wind. And then they just work backwards from that, thinking, well, if we look at maybe in a chip packet and the tiny breeze that might be doing it, and sound in itself is a movement of air, and then from that reconstruct the sound. Bizarre. But
And what they were talking about was like 1/100th of a pixel in change with high-speed photography. And that's minute.
In theory, it means that Google could write an app that would actually take Wes's lip movements, and even though he's muted the microphone, we would then have the audio overlay that we were able to reconstruct from the resonating patterns of sound on the wall behind him, and reconstruct it.
So that will be in the update next week?
It will be in the update next week, and I'm sure it will be very exciting.
And the really exciting part of that is that if he was to make a bodily expulsion, we would hear that audibly in brand new ways.
That's right.
As long as you don't have smell-o-vision.
No. But that would be part. That's just too much information. It's been really fun. I've enjoyed talking some of the STEM stuff. I'm keen on actually doing something next week with STEM if you're up for it, Amanda. I've got a group from Magnet that are keen to talk about some of the STEM projects that they're doing.
Fabulous. Sounds good.
It's
we'll
right on,
get that organised then.
Yeah, we have the Melbourne sort of shuts down on the Tuesday for the Melbourne Cup Day. That's kind of the whole
Is that important?
It is for some people in Melbourne.
This show is sponsored by Ladbrokes, ladbrokes.com.
Thank you.
So nice.
But it does give me a day off, and I'm hoping to catch up with, if it works out, Christopher Dawkins, who's coming down to Melbourne. He's been to Perth to catch up with Mark and others, and it'd be wonderful if we can catch up on the Tuesday. It's been a while since I caught up with Chris, and he's be visiting Melbourne, so fingers crossed. Anyway, stay tuned on our website if we can work that one out. Thank you.
And if you subscribe to our Google Plus community, so ACCE Learning Network on Google Plus, we'll flick you an invite for that event. And you can also view any of our recordings at our ACCELN YouTube channel, or you can find a range of playlists at acceln.wikispaces.com.
Thank you.
If you have any ideas for future shows as well, drop us a line.
That's right.
Sorry,
if you're being bothered by notifications on your Android phones, just go to the settings option and you'll be able to turn all those annoying notifications off. Amanda and I will provide tacit help and tech support for anyone who's ignored by Google Plus invitations that might pop in unexpected on their phone. I certainly look forward to seeing you all next week and next time. Thank you very much, everybody. Goodbye.
Good night or good morning.
Or good morning. Salut. Tot ziens.